You find an injured animal. You pick it up and it goes completely still in your hands. You think it trusts me. It does not trust you. It is experiencing one of the most intense fear responses in the entire animal kingdom, and it cannot move even if it wants to. What you are witnessing is called tonic immobility, and it has been documented in over 50 species across the animal kingdom. Most people know about fight or flight, but the nervous system has a third emergency response that is older than both of them. The freeze response is evolutionarily ancient, predating the fight and flight responses by hundreds of millions of years. To understand why animals freeze, you need to understand the survival calculation that happens in a fraction of a second when a predator is near. Fighting a predator twice your size almost always fails, and if the predator is faster, running often fails too. Many predators have visual systems tuned to detect movement. A perfectly still prey animal can be effectively invisible even when the predator is looking directly at it. But tonic immobility is not a voluntary decision. It is an involuntary neurological shutdown that the animal cannot simply turn off when the immediate danger passes. The biological mechanism is controlled by a structure called the dorsal vagal complex, the most ancient part of the autonomic nervous system. The neuroscientist Stephen Porges described this as the polyvagal system, three distinct neurological states that the body moves through in response to perceived threat level. When the sympathetic fight-or-flight system determines that escape is impossible, the nervous system drops into the deepest emergency mode, dorsal vagal shutdown. During tonic immobility, the heart rate drops, breathing becomes shallow, muscles lock into rigid stillness, and the body releases natural opiates that significantly reduce pain perception. The animal is not unconscious. It is fully aware of what is happening and cannot do anything about it. It can see you, hear you, and process what is happening, but the motor control that would allow it to respond has been overridden by a neurological lock it did not choose. While the rescuer sees a calm, cooperative animal, the animal is experiencing a storm of stress chemistry that is completely invisible from the outside. This gap between appearance and reality is one of the most important things anyone who works with animals needs to understand. Cortisol and adrenaline are flooding the frozen animal system. The stress response is fully active even as the body appears completely at rest. The natural opiates released during tonic immobility serve a specific purpose. If the predator begins to eat the animal before the freeze ends, reducing pain gives the animal a chance to survive the encounter without going into shock. Many predators are triggered to bite and pursue by movement. A completely still animal sometimes genuinely confuses them, buying crucial seconds or minutes. Tonic immobility has been studied extensively in sharks. Flipping a shark upside down consistently induces a state of complete muscular paralysis, lasting up to 15 minutes. The upside-down shark looks calm and even sleepy, but researchers believe it is actually in a state of extreme neurological override, not relaxation. Rabbits, birds, lizards, possums, deer, and dozens of other species all exhibit tonic immobility because the mechanism predates the divergence of most animal lineages. The opossum's famous playing dead response is the most well-known example of tonic immobility, and it is completely involuntary. An opossum in tonic immobility can remain in that state for up to 4 hours. It cannot choose to wake up, and it cannot predict when the neurological lock will release. The episode follows a predictable biological arc, but the duration is entirely outside the animal's control and varies enormously between species and situations. Most well-meaning rescuers make the same mistake. They interpret the animal's complete stillness as a sign that the animal is comfortable and tolerating the handling well. Genuine calm in a handled animal looks different. Relaxed muscle tone, blinking eyes, voluntary small movements, while tonic immobility produces rigid stillness with fixed open eyes and almost invisible breathing. Studies measuring cortisol levels in animals during tonic immobility have consistently shown extreme stress chemistry, even when the animal appears completely peaceful from the outside. When tonic immobility ends, it often ends suddenly. The animal goes from complete stillness to explosive escape behavior with no transition period. The animal does not wait to assess whether it is safe. The neurological release triggers immediate escape behavior, and motor coordination follows rather than precedes it. Even after the freeze releases and the animal escapes, the stress chemistry takes significant time to clear. the animal remains in an elevated stress state long after it appears to have returned to normal behavior. Experienced wildlife rehabilitators know that a frozen animal is not a safe or relaxed animal. It is an animal in extreme neurological distress that may suddenly become capable of defensive behavior when the freeze releases. The protocol for handling an animal in tonic immobility is designed to reduce ongoing stress input while the animal is in its most vulnerable neurological state. Covering the animal's eyes removes ongoing visual threat information, which can reduce the duration and intensity of the tonic immobility episode. The eyes, even during tonic immobility, continue to send threat information to the brain. Removing visual stimulation can interrupt that feedback loop. Slow, deliberate movement by the rescuer is also critical. Fast movement continues to signal predator behavior to the animal's threat detection system. Every moment of handling is a moment of extreme neurological stress for the animal, and minimizing that duration directly improves survival odds. And now the part of the story that connects most directly to your own experience. Humans experience tonic immobility in response to overwhelming threat, and the mechanism is neurologically identical to what happens in the deer or the rabbit. When the human nervous system determines that both fight and flight are impossible, that the threat is inescapable, it drops into dorsal vagal shutdown. The prefrontal cortex, the part of the brain responsible for reasoning, decision-making, and voluntary action, dramatically reduces activity during tonic immobility. The person is conscious and aware. They are thinking, they are feeling, but the neurological pathway between intention and action has been severed by the shutdown response. Studies of trauma survivors consistently document this freeze response, and one of the most damaging misconceptions is the idea that the person chose to freeze or could have chosen differently. The question asked of trauma survivors, "Why didn't you do something?" reveals a fundamental misunderstanding of how the nervous system responds to inescapable threat. The deer in the rescuer's hands and the human in an overwhelming threat scenario are running exactly the same ancient neurological program, written before mammals had names for what was happening to them. Post-traumatic stress disorder has a profound relationship with the freeze response. Many of its symptoms reflect a nervous system that got stuck in, or keeps returning to, the dorsal vagal shutdown state. Understanding that these responses are neurological rather than psychological has transformed trauma therapy. Approaches that work directly with the nervous system's polyvagal states have shown significant results where traditional talk therapy alone could not reach. Recovery from tonic immobility, in animals and in humans, requires time, genuine safety, and the absence of ongoing threat signals. The nervous system does not immediately register that the threat has ended. It requires ongoing safety signals to gradually move back up through the polyvagal levels. Experienced rescuers watch for the specific signs of freeze recovery: small voluntary movements returning, blinking beginning, muscle tone gradually softening from rigid to relaxed. The distinction matters critically. An animal showing no signs of recovery from freeze may actually be deteriorating medically rather than simply remaining in tonic immobility. Any animal that remains in complete tonic immobility for an extended period without showing recovery signs needs immediate veterinary assessment, because medical emergencies can mimic the appearance of tonic immobility. A conscious animal in tonic immobility will typically have warm body temperature, responsive pupils, and an audible heartbeat, signs that distinguish it from unconsciousness or shock. In every wildlife rescue involving a live animal in human hands, tonic immobility is almost certainly present, and every handling decision should account for it. Tonic immobility provides multiple potential survival pathways simultaneously, and evolution maintained it across hundreds of millions of years because it works. The response was written into the nervous system hundreds of millions of years ago. In a world where predators were everywhere and freezing genuinely could mean the difference between being eaten and surviving. Tonic immobility appears in reptiles, birds, and mammals, which means the mechanism was present in the common ancestor of all three groups, predating their divergence by hundreds of millions of years. The same neurological program running in the rabbit in your hands ran in the ancestor of birds before birds had wings, and before your own ancestors had left the ocean. Before humans existed, this scene played out millions of times in the ancient world: a prey animal, completely still, waiting for a moment of safety that evolution had programmed it to survive. And when the lock released, When the ancient system assessed that conditions had shifted enough, the animal was already running before it had consciously decided to. When you understand what tonic immobility actually is, the frozen animal stops looking peaceful and starts looking like the extraordinary, ancient, unconsciously brilliant survival system that it is. The rescuer in that moment, the one holding the completely still animal, is holding something in a state of profound neurological emergency. What the animal needs from you is not more gentle handling. It is less handling, faster decision-making, and a dark, quiet space where the nervous system can begin to recover. The hardest thing for a well-meaning rescuer to do is to stop handling the animal, put it in a dark, quiet container, and walk away, but it is often exactly what the frozen animal needs most. Wildlife rehabilitation studies have shown that animals handled with protocols that account for tonic immobility have measurably better survival rates than those handled without that knowledge. The parallel to human trauma is direct. A person emerging from freeze does not benefit from immediate intensive engagement, but from safety, quiet, and time to let the nervous system begin its own recovery. 3 contexts, 3 species. 1 response, 200 million years old, written into the nervous system of almost every living vertebrate on Earth. When you hold a frozen animal, you're holding something that evolution spent hundreds of millions of years designing, and understanding what you're holding is the most useful thing you can do for it. It is not calm, it is terrified. It is not trusting you, it is neurologically unable to move. And it does not need more gentleness, it needs less stimulation and more time. The stillness you see is not peace. It is the oldest survival response on Earth, still running, exactly as designed, in a world it was never built for.